Good evening. Welcome to a session on Java ME SDK. So my name is Robert Clark. I work for Oracle, and I'm in charge of embedded Java. So why don't we don't have a lot of time, so I want to get right into the meat of the presentation. But how many people actually went to Stephen Chin's presentation just a little while ago on Raspberry Pi embedded Java? It's quite a few. Okay, great. So that session was very much focused on embedded development using Java SE. And so this session really is focused on using Java ME for development. And I have a different device than the types of devices that were shown earlier to give you a feel for how to do development with Java ME. But before we get started into the actual demonstration, I just wanted to talk a little bit about Java ME 8 specifically. So Java ME 8 was announced at Java 1 back in September. And the main idea behind ME is that it's the little sibling of SE. It's a proper or strict subset of what you can do in Java SE, you can do in Java ME. And the focus for Java ME is on small embedded devices. As I said, so it's a major step toward the alignment between ME and SE. And the key features are an updated virtual machine called CLDC and an updated embedded profile we call it MEEP, ME embedded profile. And both of those together create the new ME 8 platform. And we have JSRs for each of those. CLDC is JSR 361. ME embedded profile is JSR, it's 360 and 361 for each of those. Target markets. Really, this slide I think is nice because it shows kind of the distinction between when you'd be developing in Java ME versus when you'd be doing in Java SE. And it's really about the platform footprint and the processor. So with Java ME, the focus is really on Cortex-M type devices, M3, M4, not Cortex-A devices. So Cortex-A devices are much more powerful. ME is targeted at the M class. And from a memory footprint perspective, ME is targeted at anywhere from dynamic memory, anywhere from about 192 kilobytes of RAM up to whatever. I mean, it can go as big as you want, but obviously once you start getting over, say, 10 megabytes of RAM, then you can start looking at Java SE. So on static footprint, again, Java ME targets around 1 megabyte of flash as the size that we're going against, and Java SE starts around 10 megabytes. So anywhere from 1 to 10, you're going to be looking at Java ME. Now this, so this device here is called the ST Micro F4 Discovery board. It is a development board just like the Raspberry Pis were development boards, but this has a Cortex M4 processor on it, and it also has 192 kilobytes of RAM and 1 megabyte of flash. So if you compare this development board to the Raspberry Pi, this is well, a very, very low-powered car, and the Raspberry Pi is a Ferrari. So this is much less capable, much less powerful, but we can do the same development experience. And one of the cool things about Java ME and what I'm going to show you is that we can do this development on these small boards, but we can also do it on the Raspberry Pi as well. So and it scales, and you can actually see how to do development in either environment. Okay, so an overview of the platform. It's based on the CLDC 8 virtual machine. On top of the virtual machine, we have the embedded profile. And the embedded profile is what gives you an application lifecycle model for applications that are deployed to the VM. There's a generic connection framework, and then there's a device access API. And the device access API is the API that gives you access to the GPIO pins, the I2C devices that are attached directly to the board itself, without having to write any native code whatsoever. And that's one of the differences, at least right now, between the ME platform and the SE platform, is that with the ME platform, you don't have to write any native code whatsoever, like you do with Py4j, where you have to actually define the interfaces that you're going to be talking to. So what we do in ME is we just simply give you a mapping of the pins, and then you can make use of them. And I'll show you how we do that. Okay, so and in order to do this development, we provide a bunch of free tools, and that's what I'm going to show you, are these tools. So the tools that we provide are called the ME SDK, Software Development Kit, and the SDK provides an emulator, so you can emulate the devices and do all your development on your PC. And then when you actually want to deploy the applications that you're writing from the emulator to the actual device, you can again use the SDK, and the SDK will discover the devices, and then you can just simply deploy and run them on the device as well. We also provide plugins for NetBeans and Eclipse to give you a unified development experience. Okay, and after we're done, I ask you to go ahead and download Java ME from the Java ME website. It's in early access right now. We're expected to go final early to mid next year, and I want you to start developing ME8-based applications. You could also develop the older ME 3.3 and 3.4 based applications, but it's based on a very old virtual machine based on 1.3. So the ME8 is a very, very big step forward in the platform for ME. Okay, so let's get out of the presentation and go to our device. So I've this device has two connections to your PC. One's simply for power, and the other is what's called the STU-Link port, which basically allows you to talk to the device over USB. Okay, so that's what I've attached. So you simply download the USB drivers for those things. I've already done that, and install them. And what we can do is set up a connection to So what I'm going to do is I'm just going to start a little program called a proxy, which starts a little program that talks to the device. Then I'm actually going to connect a PPP connection to the device. And if the connection worked, we can see that in the screen popped up that we're waiting for connections now. So we do know the device now is set up and it's working properly. Now the Java virtual machine, I did actually skip one step just because it takes a little bit longer. You have to put the Java virtual machine on the device itself. And to do that, you have to flash the Java virtual machine onto the device using the flasher program. So once that the JVM is on here, you don't ever need to change it. So it's there, and then all you simply do is deploy new applications to it. So what I now also want to do is connect to the device to see what's running on it. So what I can do is I can look at this device and I can see it gives me a listing of the applications that are deployed to the device. And in this on the device right now I only have one application deployed, and it's called LED sample 1, and it's stopped, so it's not running right now. And so what I can do is I can run it. So And I'm going to put this up here, and hopefully we can see this in the camera, and I think we can. So on this device, basically all I'm going to do is I'm going to turn a little LED on as the first application. So it says it started, and there's a little red light. I don't know if you guys could see that very well, but it just went on. And then I can go ahead stop it, and the light should have went off, and it did. Okay, so that's a simple application I've written and I've deployed to this device using the SDK. Okay, so that's pretty simple. That's something I've already done. So what I want to do now is go into NetBeans, and I want to take a look at an application. And so the development experience simply is going to be that you're going to, I should add, this is actually a special build of NetBeans that you have to download to be able to get support for ME8. So what I'm going to do is I'm just going to create a new project. My mouse is acting awfully wanky. So what I'm going to do is I'm going to create a new project, and the type is Java ME, and I just click on Java ME Embedded Application. I'm going to give it a name. And I'm going to finish. And that's it. So now I've created a sample application. And a midlet is the name of the class that you use for the application lifecycle for ME applications. So you don't have to create main methods or anything like that. You just have to define what are called midlets, and the midlets are the entities that get deployed to the runtime and then executed. So when I said AMS list, and it gave me a list of applications, those were the midlets that were deployed to the virtual machine. And essentially the life cycle for a midlet is very simple. You start it, you can pause it, and you can destroy it. So that's the simple life cycle of a midlet. And what I can do, and I'm just going to create a very simple hello world. And then I'm just going to run it. So and what I'm going to show you here is that when you're running, it gives you a choice of what you want to run the application against. So the devices that you can choose here are the embedded device 1, which is the emulator, or you can pick a real device that's attached, like the embedded external device, which is this one. I'm just going to choose the emulator for now. And I forgot to do something important. Okay. Okay, so it's going to start up the emulator and deploy the application, which for some reason it didn't do. Okay. And I ran this 7 times before I walked into the room to make sure that everything was going to go smoothly, and then of course the demo gods say no. So let me quickly kill that. Try one more time. It is refusing to deploy the application, and it's not giving me a reason why. Okay, so let me instead see if I can deploy to the actual device. So what I'm going to do is I'm going to switch to this other application that I've already written, which is the one that was actually deployed on the device that I showed you already. And what I want to do is I actually just want to show you the code and how simple it is. So again, it's the same lifecycle methods. And what I've done is import the peripheral I/O access so that I can get access to the device. And all I have to do is simply declare the pin that I want to use. And in this case, it's the type is a GPIO pin. And in order to know which pins map to which parts of the device, I simply need to go to the mapping table, which is provided with the device. So if we look at the mapping table, it's the peripheral ID is 1 for the LED 3. Etc. So anyway, all I need to do is open that device, and then set the value to true, which puts the device on. And then in the close, which is what I already showed you, you just simply set the value to false. So when the midlet exits, it will set the device to false. I set the LED to false. So what I want to do is the application that I had deployed there already put I think the red light on. And what I can do is there's 3 pins. I can change the pin, and I can compile this and I can deploy this to the actual device. And then I need to connect to the device. And you can see that LED sample 1 popped up and it's running, and the LED went on. Oops, it's not running. And now that it's running, you can see that other red light went on. And of course I can stop it, and the light went off. Okay, so, and that's where, that I didn't run anything predefined. I actually deployed that application to the device live. Okay, so the next thing that I wanted to do was to actually take a little bit more complicated application. And this one is LED sample 2, and it's not that much more complicated, but what this one does is this one actually flashes all the LEDs, okay? And in this case, all I do is I created a a flasher, which is runnable, and basically it sets a different time for each of the LEDs, and then we'll flash it for a certain amount of time. So what I can do is, again, I just take that device, take that midlet, send it to the device. Come on. Okay, well, I'm obviously having trouble here with my early access software. But hopefully this gives you some idea of the tooling that you would use to be able to create and deploy applications using Java ME. And I'm just going to try it one more time. Yeah, and we can see the application deployed this time. And it's running. Okay, so that concludes the presentation that I wanted to show today. So thank you very much for attending. I'd like to open up the floor for any questions. Yeah.
Could you explain a little bit more about how you are mapping I/O with the software?
Yeah.
This is a specific board or is a custom board or?
Right, so the question is, how do we do the mapping from the specific specific I/O ports on the board into Java ME? So the answer to the question is, when we port the VM to the device, we do the mapping for you. So you don't have to think about the mapping. So when you get a Java ME device, the ME device itself, the VM has the mapping underneath. Okay, so that's why you don't have to write any native code to do the mapping. The device access API itself is also extendable. So if there are things that aren't predefined, you can write what we call drivers in Java to be able to access those new devices, devices that are attached to the board. Okay. Any other questions? Sure.
I am not an embedded developer, but I was just wondering, could you maybe give some real-world examples of like some things that we might want to do with this?
Sure. So the question is, what are some real-world examples of things that we would want to do with with Java ME or embedded development in general. So the answer to that question is, so any sort of device that has any updatability, okay, is a use case for when you would want to write your applications in Java and deploy them to the device, because you actually don't have to flash the board every time to be able to update your application. So having an application lifecycle itself on the board gives updatability to whatever applications are deployed on the device itself. So that's one thing. And then in terms of actual real-world use cases, if the device has some sort of connectivity, which is sort of an assumption that most of these devices are useful when they are connected somehow to a network, whether it doesn't necessarily have to be an IP, it could be Zigbee or Bluetooth or a whole bunch of other types of connectivity to networks. But assuming that they have a network connectivity, the use case is to be able to gather data from the real world and send it off to some processing on the back end. So think of a health monitor that's gathering your heartbeat, and you want to detect whether the heartbeat is at a certain interval, and then if it goes above some threshold, you might want to do something intelligent on the device and then have it send it off to some back end. So if you're collecting patient data, so that's just one device, right? Then you can have in a hospital room, you might have 50 different monitoring devices that are monitoring breathing and heart rate and body temperature and whatever else. And all those devices will be collecting data. And some of them you want to have some intelligence on the device to do something. Some of them are just collecting data and sending it off to a back end. And in this case, the back end is a place where a doctor or a nurse could be looking at that data and then being able to do something intelligently. You also might want to control devices with, or control things with these devices. So any sort of, if you want to send a command to the device and have it do something. So in the patient monitoring example, if it's collecting somebody's blood pressure or heart rate, you might not want to be doing it all the time. You might want to be doing it just at certain times of the day or turn it on at certain points of the day. So being able to remotely be able to turn it on and say, okay, start collecting data for the next hour, and then shut off is a way to preserve the battery power on these devices, because you can imagine if it's running all the time, transmitting data all the time, the battery power on these would go out quickly. But in these low power devices, you want them to last for years. And so with that, you want to be able to have the control to be able to turn it on and off and do different sorts of things. So, and that's, patient monitoring is just one example. The whole home automation, where you want to control your door locks, whether when they open and close. You want to control the access to your house from say there's an issue in the house and you want to be able to unlock it for somebody else remotely, that sort of thing. Thermostats. All those types of things in home automation. There's industrial automation, be able to control the robots and things like that go back and forth. There's in cars, so telematics, you have all these sensors in your cars that are collecting data about your speed and who's behind you and what the status of the engine is. You might want to send off that data periodically to your service station so that they can figure out what's wrong with your car and how you're using it, etc. So those are just some examples. And I think there was a question there. Yes. So the question was, do I need to use NetBeans? The answer is you need to use NetBeans for this early access release, and that's simply because that's all we had time to integrate with for the first release. But when it goes GA in next year, we'll have support for Eclipse and NetBeans. And the cool thing about because we're moving to align ME with SE, you should just be able to use any of your SE tools that you normally use to be able to do your development. The connection between the IDE and the SDK. So the SDK is the thing that provides the emulator and the connection to the actual devices. The plugin to the IDE provides just that clean deployment model, being able to take the application and just cleanly deploy it right to the device. Otherwise, you can go outside the environment, have your midlet packaged up, and just simply deploy it to the app via the SDK. So when I start the SDK, that emulator window, I can take a midlet from anywhere and deploy it to a device or the emulator, either one, without having to use, so I could use whatever IDE I want. Make sense? Good. Any more questions? Okay, it looks like we're out of time anyway. So thank you very much for attending.